that we have to prove a base case. So we have to try a few different numbers and see if we get the same result on the left side of the equation and the right side of the equation. The second thing that we're going to do is assume that n equals k so that we can try to further prove that it's true for all k plus 1. Now, let's get started. First, we're going to try the left side and we're going to replace r with 1. So we're going to get 1 times 2, that's 2. Now we're going to go to the right side and replace n with 1. The 1/3 and the 3 will cancel out, so we get 2. So the base case is now proven. Now we're going to assume that n is equal to k. So all I did here was replace r and n with k. Now we're going to try to prove that it's true for the k plus 1 case. So now what we're going to do is take the summation. We're going to add in a k plus 1. So we're going to substitute k plus 1 for k. Just to reiterate that, we are replacing k with k plus 1 and k with k plus 1. So this section right here would be the next term, the k plus 1 term in the summation. Now we're also going to replace k plus 1 in here, everywhere that there is a k, and that's going to be the right side of our equation. So I went ahead and wrote k plus 1 everywhere that there is a k. This was a k before, this is a k here, k plus 1, and this is replaced with k plus 1. Now we're going to just simplify everything. Now our summation, this part right here, this summation is equal to 1/3 times k plus 1 times k plus 2. So we're going to replace this entire thing right here for this summation. So we've got 1/3 times k plus 1, k plus 2, plus k plus 1, k plus 2 equals 1/3 k plus 1, k plus 2, and k plus 3. Now we're not really going to touch the right side anymore. Now we're just going to simplify. So by looking on the left side here, we have a k plus 1 and k plus 2 in common for both of these. So we can actually factor that out from the entire thing here. So it's going to look like this. And what's left is going to be our 1/3 k plus 1. Now, you might not be able to see right off the top how these two are the same, but I'm going to show you here in just a minute. If we look at this fraction here, and if we were to factor out a 1/3 from this set of parentheses, this would be the same thing as saying 1/3 times k plus 3, because 3 times 1/3 is 1, is 3/3, which is 1. So that's how these are the same. So if we rewrite the rest of our equation here, we're going to get k plus 1 and k plus 2, which is equal to 1/3 times k plus 1, k plus 2 times k plus 3. Let's do another example. Our first thing that we need to do is find our base case. So let's try to substitute 1 and see if that works. So we replaced all the variables on the left-hand side and the right-hand side with a 1, and we're going to see if they're equal. They are equal, so our base case is proven. Now we're going to substitute n equals k. So we have our summation of k times k plus 3 equals 1/3 k times k plus 1 times k plus 5. If we were to add our summation and the next term in the sequence, it would look like this. So we're going to replace k with k plus 1. And we're going to set that equal by replacing k plus 1 in all of these instances as well. Now, since we have this summation, it is equal to this. So we are going to replace this in place of this. And we're just going to simplify along the way. Now we need to look and see what these two sets of parentheses have in common. So we are going to factor out a k plus 1 from both of them. What we're going to be left with is 1/3 times k plus 5 plus k plus 4. So essentially what we're doing is we are taking out our k plus 1 from both this term and this term. That's where it comes out front, and then we're left with a 1/3 times k plus 5 plus k plus 4. So that's everything that's happening down here. And we're trying to prove that it's equal to 1/3 k plus 1, k plus 2, and then k plus 6. Okay, let's take a look here. By looking at both of these terms, we're going to have to get creative here. So what we're going to do is we're going to factor out a 1/3 from both. And what that's going to do is add an additional 3 up here because this is technically a coefficient of 1. And if we take out a 1/3, 1 divided by 1/3 is the same thing as 1 times 3 over 1, which is 3. So we're going to write our 1/3 out front. We have k plus 1. Then we're going to have k times k plus 5 plus 3 times k plus 4. Now we're going to work inside of our parentheses here, distribute this k, distribute the 3, and then we're going to have to factor this after we get our quadratic. Factoring this is going to turn into k plus 2 and k plus 6. And if we look up here, that is exactly the same. We have just proven that.